few more things about bonds I wanted to go over. First is we had discussed that bonds are a low energy uh, phenomenon, and that's why they form because there's a, a gain by the atoms to do this noble gas configuration. So to break those bonds would require energy then, because they want to happen. Breaking them requires energy. And the bond energy increases as you form multiple bonds. That shouldn't be too hard for someone to grasp, but as you can see here, carbon has requires 346 kilojoules to break the bond, a single bond with another carbon. If it were a double bond, it would require 602 kilojoules, so almost twice as much. If it were a triple bond, it would be another 230 kilojoules above that, 835. So the more bonds there are, the more difficult it is to break them apart. And that shouldn't be too surprising. And what I told you in class is if a dad drawn here with a cup of coffee, um, here, I should keep to the same color. So here's a dad sort of wondering, what's my kid doing? Right? Like, come on, kid, get off my aunt. So if your kid is grabbing onto your ankle with his arms, it would take less energy to lose that kid off your leg than the kid who's grabbing onto your leg with both arms and legs. So a double bond would take more energy. This would be a double bond here because he has both arms and legs. Whereas here, it's a single bond. So it's harder for the dad to break free from a double bond than a single bond. All right. The other thing is that the bond length also is affected by how many bonds you have. And the more you invest in the bond, the closer the atoms become. So a single bond would be for carbon 154 picometers. A double bond would be 133, so less distance between the atoms. A triple bond would be 120 picometers. Same with a CO here. You can see CO, C double bond O, and C triple bond O, and N and double bond and triple bond. These are all phenomenon where the bond is getting smaller, and that should make sense again, even with the kid on the leg, right? This is a much longer bond situation than this situation. When you're invested more in the bond, it would take, since it takes more energy, it makes sense that the atoms are even closer together as there are more bonds. All right, then there's this beast that I didn't ever want to teach again and didn't have anything to tell you about it because I didn't teach it ever. Covalent molecular naming. So this is for binary, so two atoms. I thought I killed this, but I guess I didn't. Basically, you're going to use these prefixes to talk about the number of atoms involved. So unlike ionic, where the number of atoms involved is not at all communicated in the name, covalent naming will communicate how many atoms are involved. Notice we have mono for one. It turns out if the first element you list, there's only one of them, you don't use mono. So, for example, something like this that you're familiar with is not monocarbon dioxide, it's just carbon dioxide. So the carbon indicates there's one because it's the first element. You don't need mono. The di indicates there's two oxygens. So there's two oxygens, right? So something like H2O, though, where now the first element has two things, you don't say just hydrogen oxide, you have to say dihydrogen oxide. Now, of course, no one actually calls water dihydrogen, hydrogen. I've totally forgotten how to spell oxide. There we go. Nobody really uses this, okay? So, anyway, NH3, again, two elements. See, it's always two elements. You don't use mono nitrogen, you just say nitrogen, and then it would be nitrogen trihydride. So this is just the naming ways. You end in IDE, the second one, and it's not like ionic where you have simplest ratios and charges involved and all that stuff. So here's some more examples. CCl4 is an actual compound that you might actually run into. And so carbon is by itself. You don't say monocarbon, you just say carbon, and then you say tetra because tetra means four, chloride. And then SO2, again, sulfur is by itself. You don't need to say monosulfur. O2 would be dioxide. Uh, Dihydrogen. Oh, this is wrong still. Jeez, I still haven't fixed this. It should be dihydrogen monosulfide. Okay. So dihydrogen is H2. Monosulfide would be one. Okay. It's actually called hydrogen sulfide if you look it up, but whatever. Carbon monoxide would just be CO. So those are some examples. This really is not relevant to anything you'll ever need to do in your life. So, but there you have it.